Hello, this is Kyle Welch with RCR Wireless News. I want to thank everyone for attending Essential Diameter Capabilities, the key to scaling LTE networks and delivering next generation services, presented by Sonus. Our presenter today is Bill Welch, Product Line Manager at Sonus. Just a reminder to everyone in attendance today that within 24 hours of this webinar, we will be providing everyone with a link to the on-demand version of today's webinar. During the webinar, we encourage all viewers to submit their questions via the control panel, which we will then get to at the end of the webinar. At this time, I'd like to turn the presentation over to Bill.
Thank you, Kyle, and I'd like to thank you and RCR Wireless for this opportunity. So folks, today I'm Bill Welch. I'm here from Sonus Networks as a product manager. I'm here to discuss essential diameter network capabilities to support the LTE roadmap. Many customers are out there, many operators and wireless operators out there are either planning an LTE network, have an LTE network deployed, or are potentially layering in VoLTE into their LTE network. So there's a broad spectrum of scenarios that customers currently find themselves in, and so we're going to just discuss some key capabilities that are required for LTE. So let's talk about diameter solutions. There's various industry specifications on this from 3GPP and GSMA to define several functions that are critical to making your diameter signaling network work. That includes some translation functions, the basic diameter router, and load balancing capabilities. And this is just the start to capabilities that you'll need in order to make this network work. So going into the next level of detail here, the proxy diameter routing agent, this is the basic functionality where you're able to direct your diameter traffic from various network elements in your wireless network, and it becomes the centralized node in order to handle those capabilities. So you have basically an aggregation of network path. This is solving the n squared problem as you add nodes into the network, giving you centralized routing, and also giving you the capabilities to bind sessions, IP CAN sessions, within a PCRF, and essentially provide the load balancing and redirect capabilities with a PCRF deployment. So going into another scenario as part of the network, when you're having home and visited networks in basically a roaming scenario, you want to be able to secure that edge of the network in order to properly facilitate roaming. And so we have other critical elements of that solution is the diameter edge agent, and you have screening and routing functions, topology hiding functions, and of course congestion and flow control. So moving on into a subscription locator function, another key element in a network. If you have your network partitioned in some way, or you have your HSSs segmented in some way, you have to have the ability for the diameter agent to find the appropriate HSS. And so this will map basically a subscriber entity over to a particular HSS or series of HSSs in order to efficiently scale your network up and make sure that a single HSS failure does not basically bring down the entire network. This is going to reduce risk for the operator, improve performance as things are distributed, and also create provisioning efficiencies. So one other key element as part of an LTE network, you need to interoperate and interwork with 2G and 3G networks. This comes in a couple of forms. You have essentially the 3GPP specification TS29805, where you're interworking between the MAP protocol and the diameter protocol, and this allows basically LTE to 2G, 3G interworking. For those scenarios where you have an LTE subscriber and an LTE phone, which is now roaming onto a 2G or 3G network. And then, as vendors, you have multiple vendors in this overall ecosystem on the diameter side with multiple different elements. There may be some needs for protocol variance interoperability. And so a key element of a diameter routing solution is to be able to kind of normalize and provide an interop point between either different vendors or different vendors' version 3GPP versions that they're doing. And so this system and capability allows you to do the protocol variance and interop. So moving beyond the basics, that was really kind of the basics of what a diameter solution, a diameter routing solution needs to provide. We kind of look forward into the future on additional security, virtualization, common platforms, and SBC integration. And so looking at this slide, we have service assurance and security essentials, and those are kind of yin and yangs of each other. And so you start with kind of the basics of network access, where you want in the edge of the network, and you want things like topology hiding, DDoS and DDoS protection, high-scale encryption, and message screening. And as you move downward and to the right, you start more working into sort of the service assurance or SLA capability. So your system really wants to be highly available. This is a critical element in the overall mobile system. Geo-redundancy becomes a critical importance, and you want critical data protection and also in-service software upgrades. And then finally, from an operational standpoint, you want to be able to achieve certain SLA capabilities. So you have to have SLA assurance. You need to manage congestion as it emerges within the network, and you want to be able to prioritize and do access control. And so all of those elements, again, work complementary to each other to achieve basically a common set of goals. And so moving into the next slide, I'll spend a little bit more time on this slide. We have looked at sort of different type of virtualization options. We have the center there, the hardware approach, essentially an appliance-based implementation where you're offering SS7 and diameter signaling. We are looking at and evaluating basically a virtualized diameter and SS7 offering here, and this gives you sort of extreme flexibilities where you can essentially take a software load, put it on top of a hypervisor, and then essentially use that hypervisor to abstract the particular hardware offerings that may be underneath it from a generic COTS server perspective. And then a final offering that we're looking at is basically a network edge, essentially a hosted diameter offering. Here, essentially integrated on top of an SBC. So our SBC platform has the capabilities to do a virtualized offering and do hosted apps, and this is just one of the apps that we're evaluating. And so, actually, let me just go back for one quick second. And so these have different, your choices here are numerous, and customers need to think about, what type of solution they're looking for to lean on and which would best fit them. And so let's talk about integrating SIP and the diameter at the edge here for a moment. The SPC and diameter agent share many common capabilities. They're very much trying to, in sort of an edge deployment, trying to basically do topology hiding, provide security for the signaling, either SIP or diameter. Obviously SIP in the case of an SPC, and diameter in the case of a diameter routing solution, but also interworking between different types of clients, and doing traffic management as far as routing, flow control and congestion. And so it's natural to look at these both protocols, SIP and diameter, as a potential integration point, as they both are necessary and required to really make to basically make VoLTE work and within a network and actually make a common basically network edge point in the network. So the main point here is operating costs. You have a single common security policies, which then across the two applications, and then really gives you operational costs with that. And so obviously there's functional similarities and co-location motivate here the integration consideration. And so an integrated 4G interconnect, here's a sort of a disaggregated at the top, where you have your DRA for your core signaling, diameter signaling, and then basically your DEA edge agent on the diameter side. And so this is for interconnect between two different service providers. And then what we're talking about here is a potential integrated edge DEA and SPC, and you would still potentially have the DRA pulled out as a separate instance or separate resource. And so you have the integrated SIP and diameter at the edge of the network, and you can have essentially hosted on purpose-built hardware or potentially on some type of virtual appliance for all these different types of solutions. And so one of the things we'd like to talk about is basically the advantages of a common platform. So we have taken the approach of using a common software platform to then go after and attack solutions in the space. And so, with a common platform, we can really leverage the common code base across different hardware and software deployments. And within this common software platform, you have map solutions, diameter solutions, the inner working between those, and then obviously our SIP solution, our SIP SPC solution, where we previously announced, we have our SPC hardware appliance, and then with a common software, we have our virtualized SPC, or also known as SPC SWE. And so with a common platform advantage, you get a single point of entry into the mobile edge, seamless support of the technology migration, and not a whole lot of additional testing to be done if you migrate from a kind of hardware-centric appliance approach to a software and virtualized approach. And you end up with unified install and management and basically a simplified network topology. And so just a recap of what we've talked about here over the last couple of minutes. Here are key features and capabilities you're going to look for with basically a diameter agent type solution. You're looking for flexible deployment options, hardware, software, integrated with SPC. You're obviously looking for guaranteed carrier grade hardening. So your achievable here, on an SLA side is 5 nines into 6 nines type capability. You should look for kind of a roadmap and capabilities to migrate to a virtualization over time. Some operators may stick with an appliance for long periods of time, and other operators are looking for the flexibility to then roll out on a virtualized type environment. You're certainly looking for protocol interworking, either in a diameter to diameter sense or in a diameter map sense. And you're looking for the common platform, so it's basically investment protection. You don't want to invest yourselves into one platform and then have a forklift upgrade somewhere down the line and have different capabilities and have different interfaces you're dealing with. And then finally, integrated security. You want the security to be common across these platforms, and you want to make sure that these parts of your network are operating and capable of securing your operations. So that was our wrap up here. I am looking at a few questions that have rolled in.
Yeah, thanks, Bill. Yeah, we've had a few questions come in, and we'll get to those now. And of course, if anyone has any questions, please submit them now, and we'll get to them. Um, Bill, if you don't mind, I want to start with what kind of factors lead customers into different sort of solutions.
Certainly. So why don't I head back here to slide 9. There we go. So um, the traditional solutions for a diameter agent um, have been basically appliance-based. So in an appliance-based environment, you don't have essentially all the flexibility you're looking for with a software-centric model, but you certainly have kind of optimized performance. And so if you're looking for, to extract every basically kind of last TPS within your diameter solution, you would probably look to that. If you're looking for something that's going to go virtualized and more be more well equipped for kind of a longer term data center deployment, you would definitely look at the virtualized offering. Not saying it doesn't scale. I'm just saying that it's not as optimized as the hardware version, appliance version, as you're dealing with a virtualization layer, and that may slow things down a bit. And then on the integrated side, if you already have an SBC deployed and you're looking to add an edge agent, a diameter edge agent to your network, that makes a very easy on-ramp, and it kind of complements the virtualized offering with flexibility. But obviously, it's a common platform and common edge point to make sure your network design and deployment options a whole lot easier.
Great, thanks. The next question is, how is
Yep.
VoLTE going to impact the diameter network?
Sure. So good question. So VoLTE sort of ups the importance of it. So in a 2G or 3G network, you could certainly get away with not having kind of a diameter agent capability in your network. As you start to deploy 4G and LTE, it really becomes a critical component of that. And when you start deploying VoLTE, it's an absolutely essential. So the importance goes up by a factor exponentially. And so as you evolve your network and move forward, you certainly should consider deploying it as part of as either an LTE deployment or most definitely with VoLTE.
Great, and kind of going with that is, why would an operator choose not to deploy a diameter routing product?
So I'm not sure at this point why they wouldn't. There were several operators who were bleeding edge operators and got out kind of ahead of the curve with their LTE deployment, and they faced some rather public and rather catastrophic network failures, things that show up in trade rags and press and potentially have to be reported to regulators, and those operators quickly backtracked and deployed diameter agent solutions, diameter routing solutions, and for the most part, we're seeing all operators deploying this capability in order to protect and insulate their network from problems that these previous operators had experienced. It could be security issues. It could be vendor problems as far as an MME or an HLR having some problems, and that problem spilling over into and causing other elements to have their own issues due to kind of overload and kind of a misbehaving element in the network. You don't want that single instance problem to spill over into a multitude of problems across your entire network. So I'm not sure. I'm not sure why any operator would choose not to deploy a diameter routing product at this point.
Uh, Great, thanks. So the next one coming in is, if you integrate an SBC and diameter into a single appliance at the edge, are they still configured as separate entities, or do they share some level of configuration?
Yeah, I think you're going to find initially they're going to be somewhat separate from a provisioning and configuration and management standpoint, and then over time you'll find further integration coming over time as between the two elements basically start seeing kind of an aggregate solution, sort of a 1 on 1 equals 3 sort of scenario where the network management becomes critical to really operate both halves of the solution. So it will evolve over time. Initially, it will not be very much integrated.
Okay, great. We have another question pertaining to slide 9, which you're currently on. Have you implemented any of the modalities of the solution, such as virtualized and hosted? And what is the tendency you have seen for most operators?
So some of these offerings here are future thinking, and so they're not quite out on the market. So we've yet to see operators, embrace and deploy any of these. Well, they certainly deployed the hardware, but not some of the integrated and virtualized offerings. But we're certainly seeing operators keenly interested on either an offering itself and actually looking to deploy it here and evaluate it, or basically a future roadmap to it. I'm not sure if that quite answers the question. And let me just... So I think most operators today are basically deploying hardware-based options because that's what's really available commercially out there in the market from a competitive standpoint. But certainly they're looking for a roadmap and solution down the road, either virtualized and hosted.
Okay, great. Do you by chance have any use case scenarios for SIP and diameter interworking you can talk about?
SIP and diameter interworking?
Yeah.
Let's see here. So there are future considerations on the SIP and diameter interworking. They're in very kind of early kind of evaluation stages, and I don't necessarily have anything to share here.
Okay. We had another question asking about more insight into the hosted DSC. Do you have any insight on that?
Sure. So our SBC offering offers essentially a virtual environment that we control, and we layer applications on top of that. One of the applications that we already have available for customers is basically our PSX application, and that's essentially a call policy routing solution. And so you could have that as a separate, appliance, separate software install, or as an integrated. And we're just essentially using that same virtual environment to go ahead and essentially layer in the DSC application into that hosted environment.
Okay. I think that is about all the questions we've had submitted at this time. So, Bill, is there any other kind of closing remarks that you would like to give at this time, or anything else you would like to address?
No, so I just want to remind people that having a diameter solution is a critical element within your network, and we're seeing a great uptick in customer interest in solutions like this as they're either evolving their LTE network, deploying an LTE network, or potentially layering in VoLTE into the network. The importance of it just goes up as you add and expand your network, and you're essentially adding more subscribers and more devices into that LTE network.
Okay, great. Well, I want to thank everyone for attending Essential Diameter Capabilities, the key to scaling LTE networks and delivering next generation services, presented by Sonus. Our presenter today again was Bill Welch, Product Line Manager at Sonus. Thank you, Bill.
All right, thank you.